So today we're talking about the first derivative test. So one of the specific things, or a couple specific things that we can do, is we can find critical numbers, we can find the open intervals increase or decrease, and we can identify relative maximums or minimums using the first derivative test. So let's go ahead and first go and find the critical values. So to find critical values, the first thing we'll do is take the first derivative, but I didn't want that color. So first derivative of f is going to be 2x minus 4. So to find critical values, we set this equal to 0. So if 2x minus 4 is equal to 0, that means 2x equals 4 or x equals 2. So 2 is a critical value, not a critical point. We haven't found the y-coordinate to go with it yet, but we're not asked for that. So the first thing that I always have students do is draw yourself a number line. And somewhere on that number line, you're going to have the number 2. And this would be going towards infinity, and this would be going towards negative infinity. So what we want to do is pick our favorite number that's less than 2. Like maybe 0 works really good. So if I plug 0 into my first derivative, 2 times 0 is 0, minus 4 is a negative 4, right? So I just know that this is going to be negative, whatever it is, which means it's going to be going downhill. Then I'm going to pick my favorite number greater than 2. So say I pick, 3. 2 times 3 is 6. 6 minus 4 is 2. So that would mean that's a positive number. So that would mean that this is going up here. So if 2 is a critical value, if this is a critical value, that means that's going to coincide with being a relative minimum. All right, and that's because I'm going downhill from the left. I'm decreasing from negative infinity to 2, and then I'm increasing from 2 to positive infinity. So it must bottom out at the 2 here, because if I go back up here and I substitute 2 into this, I know it's going to equal 0. So it's going to have a 0 slope at 2. So I can, I've now found the critical value of positive 2. Now I can find the open intervals of increase. So I'm increasing, I'm going to abbreviate INC, I'm increasing from negative infinity up to, but not including the 2, because at 2, my derivative is 0. So I'm decreasing, oops, I just got that backwards. Let me go and erase. I'm decreasing. So I'm decreasing from infinity to 2. So that's why I drew the down arrow. And I'm increasing, not decreasing, I'm increasing from 2 to positive infinity. That's why I drew the up arrow here. So from 2 to positive infinity, I would be increasing. So that takes care of part B over here. Open intervals of increase and decrease. And identify relative max or min using the first derivative test. Well, we kind of did that heading into this. I know that 2 has to, where x equals 2, has to be a relative minimum. If I wanted to find the critical point, let me write down critical point, I would have to go back and substitute 2 in place of the original function. So 2 squared is 4, minus 4 times 2, which is 8. So 4 minus 8 is negative 4. Let's go back down here. Negative 4. So if I were to graph this function, I know there's a right 2 and down 4 is my relative max. So, or relative min, sorry. And just a quick sketch, I know it's going to go up to the, from here, it's going to go up towards infinity, and from here it's decreasing from negative infinity, and it's ending up at 2. Now remember, at 2 we have a slope of, let me undo that, a slope of 0. So the tangent line has a slope of 0 where x equals 2. So that is one of the first applications that we use to compute critical numbers, obviously, first of all, and our open intervals where we're increasing and decreasing, and identifying relative maximum and minimums. Okay, so let's look at another expression. F of x is equal to x to the 5th minus 5x all over 5. So I want to do the same thing. I want to find the critical values. So the first thing I'm going to do is take the derivative. So f, whoops, let me undo that, f prime of x. Okay, notice here that we have a fraction. So I'm going to have to use the quotient rule. So I'm going to take the derivative of the top times the bottom minus the derivative of the bottom times the top. And then I'm going to divide the whole thing by the bottom squared. So let's go ahead and do that. So the derivative of the top, let's see, that would be 4x, no, let's back that up. That would be 5x to the 4th. That's where I was getting my 4 from, minus 5. So that's the derivative of the top times the bottom, 5, minus the derivative of the bottom, which is 0, times the top, which is x to the 5th minus 5x, all over the denominator squared. So 5 squared is 25. So we're going to square 5 to get 25. So notice that this goes out to, that goes to 0, because 0 times anything is 0. So what am I going to do here? Let's see. I'm going to simplify my derivative by taking out another 5. I have 5x to the 4th minus 5. So I can take out another 5 and combine it with this 5 to make 25. So simplifying, I have f prime of x equals 25 times x to the 4th minus 1 all over 25. And naturally, we're going to see that these 25s cancel out. So we end up with x prime of x is equal to x to the 4th minus 1. So if I want to find critical values, I have to take this first derivative and set it equal to 0. So let's go ahead and do that. So set that equal to 0. So I notice here I have the difference of two perfect squares. So that ends up being x squared plus 1 times x squared minus 1 equal to 0. This factor does not, this factor doesn't break down anymore. It's still x squared minus 1. So just going to copy that down. X squared plus 1. I said minus 1. But this x squared minus 1 is the difference of two perfect squares also. So that could become x plus 1 times x minus 1, and that's all equal to 0. So what do I want to do? I want to figure out what the zeros are here. So I have, let's see, this is going to be x squared equals negative 1, which is going to give me a plus or minus I, right? So that's not a real number. So that doesn't really cross the x-axis. Over here, for this factor, I have x equals negative 1. And for, that's this factor here. For this factor, we would have x equals positive 1. So my critical values are negative 1 and positive 1. So something is going on at negative 1 and positive 1 of this original function up here, x to the 5th minus 5x all over 5. So what is that happening to be? So to find our critical values, or to find our where we're increasing and decreasing, somewhere along the line here, I have a 1 and a negative 1. So I have to pick my favorite number less than negative 1. Let's see, what could that be? That could be maybe a negative 2. So negative 2 times negative 2 is 4, plus 1 is 5. Negative 2 times negative 2 minus 1, that's positive. So I could also go all the way back up to the original derivative. Negative 2 to the fourth is 16 minus 1. Don't care so much exactly what that is, other than it is positive. So that means in this interval, say from negative infinity to negative 1, we're increasing. Then let's see, we got to pick another number. Our favorite number between between negative 1 and 1 is, for me, that happens to be a 0, because 0 to the fourth is 0, minus 1 is negative 1, so that's a negative number. So that means I am decreasing in this interval from negative 1 to positive 1. I'm sorry, I wrote the wrong thing in there, 1. Then out here, we're going to pick our favorite number bigger than 1, substitute it into any of these expressions. Say we pick a 2. 2 to the fourth, that's 16. 16 minus 1 is 15. So it's positive at any rate. So that means that we are increasing in this neighborhood. So from 1 to infinity is an increase. So this is increase, this is decrease, and this is increase. So the last thing we wanted to find out is does this occur, negative 1, at a relative maximum or a relative minimum? Well, if I'm increasing to the right and decreasing to the left, that tells me that this is a relative max. And then if I look over here at this one, I'm decreasing to the left and increasing to the right. That tells me that this is a relative minimum. I'll abbreviate that so it fits into my things here. So if I wanted to find critical points, I would have to go back to my original function to substitute negative 1 and positive 1. So the original function, see, negative 1 to the fifth is negative 1, minus 5 to the negative 1. Let's see, that would be 5. So negative 1 minus 5 is 4, so 4/5. So I would have a critical point, which you weren't asked for, but a critical point at negative 1 and 4/5. And another critical point would occur at where x equals 1. So 1 to the fifth minus 5. That would be 1 minus 5, or negative 4 over 5, which would be negative 4/5. And what we could have done is naturally typed this into a graphing calculator to get these values, and also to find out that we were increasing in this interval, decreasing in this interval, and increasing in this interval, and that this was a relative maximum and this was a relative minimum. But we're able to do that analytically by using our first derivative test. So there you have it, first derivative test. Remember, practice these, do all the practice problems that your teacher gives you, because practice makes perfect. You can't get better at this if you don't practice it. So I always say math is not a spectator sport. So we have to make sure that we're doing everything we can to improve our ability to score high in these tests.